Greetings, eco-nerdlings. In this podcast, we're going to be discussing water usage. So before we get started, I wanted to give you this quote. When the well is dry, we learn the worth of water. So in a previous podcast, we talked about the hydrologic cycle, and it describes the mechanisms by which water moves throughout our earth. So we have heat coming from the sun, and that causes water to evaporate from rivers, lakes, streams, oceans, or the soil. We also have plant roots that extract water, and eventually that water is lost through the process of transpiration. As the evaporated water moves up into the atmosphere, it loses heat and then it condenses into clouds. Once it's condensed into cloud, then we get to see precipitation. And precipitation occurs in the form of rain, snow, sleet, ice, hail, all of that good stuff raining down from above. So some of that water will eventually form runoff, and that's what moves towards lower elevations and it starts collecting into other body surfaces of water. The rest of the water actually soaks into the soil, and we call this the process of infiltration. So at any given time, only about 3% of the world's water supply is fresh water, and the rest of it is located in all of our oceans. The majority of fresh water is actually frozen in the form of glaciers. And another 20% of that is actually underground. So only 1% of fresh water is readily available to us at the surface. That's quite a little bit of water when you compare it to the amount of water that you see in all of the oceans worldwide. And that's basically kind of what we're fighting over all of the time. So water use is measured in two different ways. We have water withdrawal, and then we have water consumption. Water withdrawal measures the total amount of diverted water within a source or withdrawal from that source. So for example, if we use water to cool down a power plant, we're going to withdraw that water from a river, we're going to use it to cool down the power plant, and then it's going to be returned to that actual river. Whenever we consume water or water consumption, that measures the water that we permanently remove from that original source. So for example, if we spray water on our crops for irrigation, then that evaporates or it transpires into the atmosphere and it's not returned to its original source. So looking at this is the water withdrawal as well as water consumption in the United States. One thing I want to point out is looking at irrigation and livestock. So 41% of water withdrawal and 85% of water consumption is actually used for irrigating crops and for maintaining livestock. That's a huge percentage of our water use. So one of the case studies we're going to discuss is called the Salton Sea. The Salton Sink is a waterless depression in the southeastern California, and it was part of the Sonoran Desert. At one point, the sink was actually the bottom of a huge freshwater lake. So the Salton Sink was an area that was experiencing water scarcity, meaning that there was not enough access to fresh water to drink or to grow crops, to maintain livestock. And a lot of times countries that experience water scarcity are those countries that tend to be very dry, and they also tend to be very heavily populated. So in 1900, a development company began constructing irrigation canals to divert water from the Colorado River into the Salton Sink. That land actually became very, very fertile. They started growing crops and everything like that. That all was planted there for our consumption. And then in 1905, we had a very, very heavy rainfall, which caused a snow melt later on, and that caused the river to swell and breach the dikes as well as the canals. So two of the rivers were carved out, causing the entire volume of the Colorado River to empty into that sink, or the Salton Sink. And eventually, that began what was called now the Salton Sea. So when we have areas of the greatest aquifer depletion right here, so our aquifers are where our water is stored underground. So areas of the greatest aquifer depletion from groundwater overdraft in the continental U.S. are showed right here on this map. So if you look here, the area in red is going to be the most depleted. And if you look again, it's going to be New Mexico, which is extremely, extremely dry. The northwestern side of Texas, again, is extremely, extremely dry. And then the areas around it are going to be kind of moderate. But right here is going to be the largest depleted aquifer that we have. The Ogallala, which is the world's largest aquifer, is most of the red area in that center of the Midwest that I was just pointing out. So the Aguayala Aquifer. This is the world's largest known aquifer, and it fuels agricultural regions in the United States. It extends all the way from South Dakota to Texas. It's essentially a non-renewable aquifer from the last ice age with an extremely low recharge rate. So in some cases, water's pumped out about 8 to 10 times faster than it's actually replenished. But from the south, it's starting to get thinner and thinner and thinner. It's estimated that about a quarter of the aquifer will be depleted by the year of 2020. So how do we access groundwater? Well, groundwater is located in a region of soil called the zone of saturation. This is where all of the spaces between the soil particles are filled with water. So we have our zone of aeration, and then right here, our zone of saturation. And again, that's where all of those spaces between soil particles are going to be filled with water. So aquifers are underground regions of soil or very porous rock that are saturated with water. If the aquifer is physically separated from the groundwater, it's called a confined aquifer. So right here, we have our confining layer and our confined aquifer. If it's not separated, we have an unconfined aquifer. Regions where the water can infiltrate the soil and reach the aquifer are called the recharge zones. In most of the United States, crop production takes place in the Great Plains, and these are areas that are very, very far away from natural lakes or natural rivers, so we have to use the process of irrigation and withdraw water from other sources in order to water those crops and maintain the agriculture. So water for irrigation here is mostly taken from the Aguayala Aquifer. So we have a huge problem with overconsumption of fresh water. So excessive water withdrawal from the aquifers can cause a lowering of the water table, and that's actually called a cone of depression. So looking right here, this would be an example of a cone of depression. One of the bad things that occurs if someone takes off that water from the water table and they start drilling a deeper and deeper and deeper well, areas around it that have shorter wells are going to start to run dry. So wells that are located near the ocean can also experience problems. They can experience a problem with saltwater intrusion. So instead of their freshwater well only having fresh water, now we get an invasion of saltwater as the ocean water mixes in with that groundwater. And only about 1 inch of precipitation actually reaches the Aguayala Aquifer annually. And that's obviously far, far less than what we're removing from that aquifer to irrigate our crops, to water our livestock, as well as use water for ourselves. So excessive groundwater consumption can also lead to a problem called subsidence. This is an actual compression and sinking of the zone of saturation. So the San Joaquin Valley in California has experienced subsidence of up to 28 feet. So looking at that, that's telling us that the ground used to be way up there, and it has basically been compressed and compacted over and over and over throughout the years because of the excessive use of groundwater. Well, I hope that was helpful. If you'd like to review this video or watch any other videos, you can find them at www.nerdlingscience.com. Well, that's all for today. This is the Queen Nerdling signing off. Stay nerdy until next time.